Okay, so now that we've got all of our ripped sprites, what we're going to do is open up a new Unity project. I've opened up a new 2D Unity project because this game is in the 2D world. So I'll just drag in our ripped sprites. I'll grab in the cutscenes as well. And now you'll see when we go to look at our sprites, they're all just one big image. That's because on the right hand side in the inspector, we'll see that our sprite mode is set to single. Now we don't have just one sprite on this sprite sheet, we have multiple. So we're going to click on that drop down and change it to multiple. We can go ahead and apply that, and then we can open up the sprite editor with this button here. Now you'll see we get this window that opens, and what we're going to have to do is slice all of our sprites into individual objects rather than having one big image. And we can go ahead and use automatic and click slice, and it does a relatively good job of selecting individual sprites, but you'll see on these two they are two joined together, but for the most part it does a good job, and you can easily go in and edit them by deleting these extra ones and expanding this box to include all of the sprite. There we go. So that's how you would edit the sprites individually. So what we're going to do is get started with animating an enemy. So we'll go across to our enemy sprite sheet, change it to multiple, open up, click apply, open up the sprite editor, and we'll see what the automatic slice tool will do for us. Let's see, it's done, yeah, that's done a good job, that has. It's got all of our individual sprites, we've not had to adjust anything. I'm sure once we get animating we'll have to adjust things then, but for now it's done a very good job. So we'll click apply, and then we can get back to our scene. So first things first, what we're going to want to do is get this looking like Rodland. At the moment there's nothing in the scene. So if we go into Rodland stages, we can find our stage 1 image, and we'll just drag it into the hierarchy on the left hand side. Now we'll see it's far too small, so we can just resize that. We'll put it to 4 on the scale, and now if we look at our main camera, it's not too bad. It's a little bit cut off, but we can deal with that later on. Right, now we're going to need to make a new game object. We can call this Spud because that is the enemy that we will be creating. This yellow character here, he is called Spud in the game manual. So what he's going to need is a sprite renderer so we can see him, and we can just add in an image so that we can see him there. We'll put the order in layer to higher than the background so that we can see him on top of the background, and we can up his scale to 4 as well. I'll just move him up to the top here. So what we're going to want to do is add a animator component, and we can also add a rigid body 2D component. We'll set that to kinematic because we will change his positioning via script and not via the Unity physics engine. And we will also want a capsule collider 2D. Now that's done a good job of highlighting himself, so we don't have to do anything with that right now. Now if we go into our assets and we create a new folder, and we can call this animations. We'll create a new folder inside animations called Spud, and then we can create a new animator controller, and we can call this Spud controller, and we will assign that into the animator component on the Spud game object. There we go. So now what we can do is start animating Spud. So what we're going to want to do is open up the animator tab by clicking add tab and animation. There we'll get this new window down the bottom where we can click to begin animating Spud, create an animation clip, and that's what we would like to do. So we're in the spud folder, and we can change the animation name to walking animation spud, just so that we know whose that is. And here we go. So the way animation works for simple game objects like this, we will just be changing the sprite renderer image to another image to make it look like he's walking. So it's fairly simple for this game. The walking sprite, I believe, is 4 or 5 images, so we can drag the animation window to the side and find all of our enemy sprite sheets. Here they are. Okay, so to begin animating Spud, what we're going to do is drag our sprites from our sprite sheet into the animation window, and we'll create a timeline of sprites to cycle through to make it look like he is walking. So we are just going to need to find the right sprites, which looks to be this one for the first frame, and then we need the, looks like this one to be the second frame. Just click on Spud so we can see, and then next frame we will want this one down here. After that we are going to need him to get a little bit squashed, so that looks like it's this one where he's wider at the bottom. And then finally we will want the first animation frame again. So if we play this, he should cycle through the animation. Now unfortunately he's not bouncing up and down, so the way to fix this would be, well, you could do it multiple ways. You could do it via code, however that would be needlessly complex, when we can just find the sprite where he should be lifted up off the ground, and we can drag the sprite so it looks like he is now levitating off the ground. Click apply, and then we can click play again, and now he hops off the ground. Now we can tidy this up a little bit by adding extra frames if we have extra frames, or creating it so that he's not immediately slamming back down to the ground after he has hopped. So we can choose this sprite, it was this one here. If we drag this frame down as well, we'll create this to be a little bit longer, and click apply, and now we can click play, and he bounces up and down, and that looks fairly convincing. If we move his positioning just down a little bit, make it look like he's bouncing off the ground, and ton of gizmos. Yeah, that looks pretty convincing. All we need to do next is create the movement script so that he moves from left to right. So to do that, we're just going to pause the animation, and we can create a new folder. We'll just call it scripts for now, just so that our assets folder is all nice and tidy. And we can go across to Spud and click new script, enemy movement, we'll call it that, so that we can use this for multiple enemies and not just for Spud. We'll wait for this to compile, and then we can open it in Visual Studio. Okay, it's finished. We'll click edit script. Okay, so we can for now just delete these top two at the top, and we'll just type in, what do we want? We want to get a reference to our rigid body, so public rigid body 2D, we'll just call it RB, and we can get this in the start function if we just do RB equals get component rigid body 2D. And then what we want to do in our update is just we can just call another function called move enemy, and then we'll create this void function, void move enemy. So what we're going to start off with doing is just by making the enemy move in one direction, and then later on we can add it to detect a wall and flip the sprite and then move in the opposite direction, so it looks like it's bouncing between walls. So to do that, we'll just make it move in one direction. We'll just change the velocity to a new vector2 of, we will create a public float of movement speed x, and we can make this a 3f. So we'll create a new velocity, new vector2 of movement speed x, and it can just be whatever the rigid body dot velocity y already is set to. Okay, so this should, in theory, move it to the right direction. Let's see. We've got our capsule collider, rigid body. We can set our rigid body by dragging it into the inspector. However, if we do forget, our script should do that for us. We'll click play and see what happens. Okay. So he's moving to the right and he is animated. The only problem is he is flipped the wrong direction, but that's fine. What we will do instead is move him to the left by changing the movement speed x to -2. So now he'll move to the left and we won't have to do anything with his scale or flipping his game object just yet. We've lowered his speed, so he should move a little bit slower. And that looks pretty good. He's happily bouncing along the screen, and he will do that forever because he's not detecting any walls. So what we'll do next is create some boundary game objects. So we'll just call this left wall and add we'll give it a box collider 2D renderer. And we will just assign it to a random sprite. We'll just assign it to this for now and change it to black so it doesn't look like it's anything in particular. And we can change the height by changing the width or the height. To do that, we will just drag this number up. What I like to do is just adjust the scale so it does it much faster. And we will create a left wall. We'll need a right wall, so I'll just duplicate that by using the Control and D key, and we can drag that over to this side. Now these already have colliders set up, but they're not quite to scale, so I'm just going to click reset on those so that it sets to the size of the image. And now we've got two boundaries on the left and right hand side. Now in order to detect these walls, what we're going to do is use something called a raycast. Raycasts are fairly straightforward. You essentially shoot a laser from wherever point you would like to shoot the laser from, and you can give it a distance, so it shoots from the game object to just in front, so it can detect a wall and then turn around and then go off in the other direction. So what we're going to do is go back into our enemy movement. We will change our move enemy function to have a raycast. So the way we are going to want to detect walls is when we are looking for a wall, we will not want it to be blocked by any other game objects. So for example, if a player is standing between the game object and the wall, we will want to ignore the player and check for the wall, and then we will be able to flip based off of that. Otherwise we will get confused because the raycast will only see the player instead of the wall, and it won't flip. So in order to do that, we will just create a wall layer. So we'll do public layer mask wall layer, so we know which is the wall layer, and we will assign this in our hierarchy later. And then we can get started on a wall check. So to do this, we'll do bool we'll do 2 wall checks. You can do it with just one, but for simplicity we will just do wall check right and wall check left. So we'll do a physics 2d.raycast, and we want to go from transform.position to vector2.right, and we will do it by, well, we need to have a distance, so we will create a float of wall check distance, and we'll change this to maybe 0.5f, and we want this to be on the wall layer, so we're not checking for anything else. And then we can duplicate this, and we'll just change it to wall check left, to left here, and then wall check distance can stay the same. Now we can visualize these raycasts by adding in a on draw gizmos void. So we'll just do, this can just be a private one, void on draw gizmos, and we will do gizmos.drawLine new vector2 from where are we going from transform dot position to transform dot position plus wall check distance. Okay, we'll have it as a vector transform.position.x. We'll need to do transform.position.y because it didn't want to convert from a vector2 to a vector3, so we'll do new vector2 transform.position.x transform.position.y. So we've converted the game object's position into a vector2, and we will want to move this to a new vector2 again of transform.position.x plus wall check distance to transform.position.y, and now hopefully that should be visualized in game by a small line. If we turn on gizmos, we should see there is our wall check. Now it's pointing to the right, but that's fine because we've got, via code, we've got a draw line for the wall check right and a wall check left. So now what we need to do is check if that is actually detecting a wall, which is fairly straightforward, seeing as we've already got a ball here. So we can just do if wall check right, wall check right, we will want to flip to the left. We'll create this void in a minute. Or if we do if wall check left, we will want to flip to the right. Now we can create these void functions. Void flip left. Now these are going to be fairly straightforward. What we're going to do is just change the scale of our game object to the reverse of itself. So we can do vector3 current scale equals game transform.local scale, and we'll do current scale dot x times equals -1, which will invert the scale. This needs to be a lowercase g. And then we can change the movement speed as well, because we will need to start moving in the opposite direction. So we'll do movement speed x equals movement speed x times equals -1, the same as the line above it. And we can also do the game object dot transform dot local scale equals count scale. Now that needs to be a lowercase g. That's the flip left, and then to do the flip right, it's essentially just going to be the exact same. The reason we're going to need 2 is that we can also define whether we are facing right or facing left. So we can go down here and do facing right equals facing right, and we will create this as a bool at the top. Public bool facing right. Now honestly this should be facing left because our game object is currently facing to the left. What have I done here? That needs to all be lowercase. So, okay, now that is happy. So facing right is false by default because he is currently facing to the left. So he'll be moving to the left. Check for a wall on the left hand side, and if it is, then it will flip to the right, which will then flip the scale of our game object, and hopefully he will start moving to the left. So if we go back into Unity, what we need to now do is define the wall layer, and to do that we're just going to create a new layer. We'll call this wall, and then we'll assign this to our 2 left and right wall boundaries, and now they're tagged as wall. And in the enemy movement we will select wall. Now if we click play, we can see what happens. We'll see if we manage to fix this first time or if there is some issues. So he's happily bouncing along. Will he detect a wall and flip? Yes, he detected the wall and he's flipped, and now he's moving in the opposite direction. You'll see on the bottom right hand side the ball of facing right gets ticked and unticked as he hits the wall,